This noise only will come. So 1 gram of steam at 100 degrees Celsius melts how much ice at the 0 degrees Celsius? Latent heat of ice is this and latent heat of steam is this. So you have to understand this as the heat lost in converting steam at 100 degrees to water at 0 degrees Celsius should be equal to, here you can understand, steam at 100 to water at 100, then to water at 0, then the reverse way you have to consider. The water is this state, now the amount of heat required for ice at 0 degrees Celsius to convert into water at 0 degrees Celsius, how much heat required, this will be same only. Heat energy is the heat lost by this to come to this water this state is equal to the heat gained by ice to come to the state will be equal. So by using this we can say that, so how much mass of ice should be there to come so that how much mass of ice should be there to come to the water at 0 degrees Celsius with this process, so that here if 1 gram of steam is converting into the water at 1 gram of water at 0 degrees Celsius. That is the question. When it is we are dealing with ice, the mass will changes. So based on this condition you will get a mass of ice, that is you can take it as final mass or mass of ice. This is mass of steam and hence it is mass of water, and here this is mass of ice. Here this you can take it as a final mass of ice is equal to, in this process change of state is taking place when the steam at 100 degrees Celsius is converting into water at 100 degrees Celsius. Change of state will take place, no change of temperature will take place, only entire heat liberated is used for change of state. Then but when the water at 100 degrees Celsius is converting into water at 0 degrees Celsius, temperature changes, no change of state, only the same state but temperature changes. So the heat liberated is given as mc into delta theta. During change of state heat liberated is taken as ml. So in this process again, when ice is converting into water, change of state is taking place. We can take it as the heat liberated is heat absorbed is taken as m into lf or m into l, latent heat of fusion you can take. So latent heat of fusion into mass corresponding to that fusion is given by this. So we can take this for instance. Next question. So to understand this, you have to understand that there is a liquid drop of radius r at some temperature. Now, if you give some heat, obviously temperature may change, but without changing temperature, by maintaining same temperature, if it is evaporating, means change of state is taking place. You can say the heat given is using for change of state, so temperature is not changing. It is using for only evaporation purpose. That means whatever the energy it is having, change in surface energy of this is equal to the change in the heat energy. It will be resulting into the heat energy which is using for change of state. Okay, the whatever the surface energy it is having, a part of this, when you are giving heat, the energy is utilizing for change of state. That means to evaporate, so it will not increase the temperature, so it will remains constant only. That means the surface energy of a liquid drop in terms of surface tension, you know that it is equal to T into change in surface area, but amount of energy it is utilized for a change of state to evaporate is nothing but ml for change of state, mass into latent heat of fusion. But here, to understand these relations, we have to make use of this simple points. What are these things here? If you have the surface area of a liquid drop is equal to 4 pi r square, then change in area can be taken as 4 pi into 2r delta r, 2r delta r. This should be 2r delta r. Similarly, if density is equal to mass by volume, and from this you can say mass is equal to density into volume. Why we need, you may ask here, to understand it this mass is not given, but in terms of radius, radii you are dealing with, so we have to convert this into radii and density part. For that purpose, I have to take this one. So density is equal to mass by volume, so mass is equal to density into volume. Here density into volume is 4 by 3 pi r cube, so m can be taken as what do you call, substituting this, you can take it as here what we are taking here is uh, m into l. So the change in volume, actually rho into the change in volume, you have to take it here, change in volume. So but the if volume as volume is because volume V is equal to 4 by 3 pi r cube. Change in volume can be taken as 4 by 3 pi into 3 r square delta r, 3 r square delta r. So that so we can take it as because of that we can take this is rho into this is not the volume, this is volume, but you have to take the change in volume here. Rho into change in volume is 4 by 3 pi into 4 by 3 pi into 3 r square delta r. So this, and simplifying, you will get this m is this one. Now this delta a and m, if you substitute here, you will get this relation delta a and m. And simplifying further into see into L, you have to take L latent heat. Then you will get R is equal to 2T by rho L. That's it.